Now the next topic is approximation. What is meant by approximation here? Clearly in interpolation, we approximate the function f of x by a polynomial, right? Using interpolation we can find only a polynomial p of x, or sometimes one can write capital F of x, right? Only polynomial, but in general or in special cases, the function f of x may be approximated by the trigonometric or rational and other functions, exponential, other functions, maybe exponential, just exponential, etc. Okay, other functions. Now the existence of, that means here what we are doing in this approximation, we are approximating the function f of x by either a polynomial or any trigonometric function or any other exponential function or a rational function. Okay, now the existence of a polynomial function. What is the polynomial function? P of x, which approximates any continuous function f of x, on a finite interval a comma b is guaranteed by the Weierstrass theorem. Weierstrass approximation, or one can say Weierstrass approximation theorem, which states that what is the theorem statement? Weierstrass theorem statement is, one can write Weierstrass theorem statement is, if a function f of x is continuous, on a finite interval AB, then given any epsilon greater than 0, small epsilon is very small value, given epsilon greater than 0, there exists an eta. What is eta? It depends on epsilon. Eta of epsilon and a polynomial p of x of degree n, such that what is the thing? The difference between the function and the polynomial, the error, nothing but the error, f of x is exact polynomial and p of x is approximate polynomial. The error must be very, very small. For all x belongs to closed AB. That means the error should be very small. That is called Weierstrass theorem. Now, in order to determine approximation, an approximation to f of x, here we assume an expression of the form. Here we assume an expression of the form. What is the form here? Expression of the form f of x. It is approximated by p of x. And what is p of x here? It is taken as p of this function contains arbitrary constant Cn. And what is this is given by? This is C0 into some phi naught x plus C1 into phi 1x and so on, Cn into phi nx, Cn into phi nx. This is the approximation. Take this as equation 1, where these functions phi ix, I equal to 1 to n, are n linearly independent functions. We have to choose these functions, okay, linearly independent functions, and ci I equal to, this is 0 to n, ci I equal to 0 to n are parameters, arbitrary parameters are to be determined. We have to find these constants. Then the approximate polynomial p of x will be determined. And the point is, one more, the functions this phi ix are called coordinate functions. Sometimes these are functions also called shape functions, and are usually taken as phi ix equal to x to the power of I, where I equal to 0 to n. For what is this approximation? This approximation is for polynomial approximation only, not any other function. Polynomial approximation. Therefore, the error of approximation is, what is the error now becomes, actually what is the error? Modulus of f of x minus p of x. Approximation is, the notation is now e, f, c, arbitrary constants are there. What is the error? It is taken as f of x minus p of x, right? So that can be now taken as norm is nothing but one value. This is nothing but what? C0 phi naught plus C1 phi 1 of x, these are x and so on, plus Cn phi n of x. Okay, now this is the error. In the approximation by assuming the polynomial as this function. Here the norm is well-defined norm. Let us see how it is defined later on. Okay, now we have to find the arbitrary constant ci, so that the error should be minimized. We have to find the parameters ci to minimize the error. And let us see how many the most commonly used norms. This is the case 1 for discrete data. Discrete data means I can count the values like C1, C2, Cn, like that. I can count the values. Okay, first one is LP norm. This LP norm is defined as norm x equal to summation I equal to 1 to n, the data values x1, x2, x3 and so on, xi modulus of xi power p, and this whole power 1 by p, whole power 1 by p, and p must be greater than or equal to 1. Okay, here what are the discrete values? Here x equal to xi nothing but this is x1, x2 and so on, xn is a sequence of real or complex numbers, this is LP norm. And next one, Euclidean norm. Next one is what? Euclidean norm. Euclidean norm. What is this definition? Norm x equal to summation I equal to 1 to n mod xi square and whole power 1 by 2. Whole power 1 by 2. That is, what is the p value here? That is, in LP norm, take p equal to 2. LP norm p equal to 2. And this is also called as square norm. This is also named as square norm, also called square norm, and denoted by sometimes this is in textbooks, it is norm 2, norm x2. And the next one is uniform norm. What is uniform norm? Norm x equal to maximum value of mod xj. Where is j? That's it. That means in x1, x2, xn, take modulus values of every value and take its modulus, then pick the maximum value. Here p is taken as infinity, uniform norm or infinity norm. Now discrete data is over. Discrete data means x values are countable. Now for continuous data. What is continuous data means? Here, if the function f of x is continuous, on closed AB, and f of x is integrable, and one can write mod f of x power p is integrable on AB. That means function, no data is given, data points are not given, function is given, so function is continuous. Then the first norm is norm f equal to, continuous means always you will get integration a to b w of x mod f of x power p dx. Okay, power p dx, this whole power 1 by p, this p greater than 1. This is called Euclidean norm, or this is called LP norm, this is called. And here what are w of x greater than 0 are weight functions, or is weight function. We have to choose this weight function, and in particular when p equal to 2, what is norm f equal to? This is integral a to b w of x mod f of x square dx whole power 1 by 2. This is called Euclidean norm, or simply called L2 norm, or what is the another one? Square norm. Okay, and for p equal to infinity, that is uniform norm, p equal to infinity, we have uniform norm, norm f equal to, what is that? Same, maximum of the function, modulus of the function over what interval? Over the interval a to b. These are the norms, and it is denoted by what? it is denoted by L infinity norm. This is denoted by L infinity norm. Generally we use square norm.